what I want to go ahead and do today is I want to go ahead and look a little bit more at the electrons. Now, before we go ahead and start looking at the electrons, if you remember when we look at a periodic table, this whole number up here on the periodic table, for example, number 7, that tells you that we have 7 protons in the nucleus of an atom. Now, remember that number is called the atomic number. For example, arsenic, number 33, that has 33 protons. But if you remember what we said the number of protons and the number of electrons were going to be the same in an atom. Now, like I said, what I want to do is I want to go ahead and focus a little bit more. Again, when you start thinking about our current atomic model, we said our current atomic model had the protons and the neutrons sitting inside the nucleus of an atom. And on the outside in these orbitals were going to be the electrons. Now, like I said, we're going to focus basically on the electrons today. Again, if you remember, we said that there were going to be 7 orbitals or energy levels. Now again, talking about these electrons, what we're going to do is we're actually going to place these electrons. So what I want to do is I want to go ahead and look at the template for orbital diagrams. So template for orbital diagrams. Now for these orbital diagrams, all we are going to be able to do is look at the first 3 levels of these electrons. So let me go ahead and kind of clear this off right now. Okay. For the first orbital can hold a maximum of 2 electrons. So the first orbital, maximum 2 electrons. So what we're going to do is draw our first ring around here, and I'm going to go ahead and put a 2 electrons there. In the second orbital can hold a maximum of 8 electrons. Now, you always have to make sure that you fill that first or the inner orbitals first. Okay, so you would have to fill those first 2 electrons in the first orbital. Once you got to electron number 3, then you'd have to jump out to that second orbital. So again, the second level can hold a maximum of 8 electrons. And our third orbital can also hold a maximum of 8 electrons. So if you add all of these electrons up, you're going to notice that we have a grand total of 18 electrons that we're going to be looking at. Now again, when we talk about the periodic table, the thing is that periodic table is really going to be made up of patterns, and we're going to be talking about a few of those patterns in just a little bit. But again, level number 1, 2 electrons. Level number 2 can hold a maximum of 8 electrons, and level number 3 can also hold a maximum of 8 electrons. Well, what I want to do is let's go ahead and look at, for example, hydrogen. Hydrogen has 1 electron. So if we go ahead and look at hydrogen, and again, all I'm going to do is, for example, just put an N here for the nucleus. And because it only has 1 electron, we're just going to go ahead and place that 1 electron right there. Now, if we go ahead and look at oxygen. Oxygen, when we go to the periodic table, finding up here number 8. So again, it's going to have 8. So what I'm going to do is I'm going to go ahead and place 2 in this first ring. And I'm going to go ahead and place 6 in the second ring. And when you go ahead and add these 2 rings up, 2 plus 6 gives me my grand total of 8 electrons that I needed to place for oxygen. When we go to chlorine, looking at a periodic table, it says chlorine has 17 electrons that we need to place. So, 17 electrons. Draw our nucleus here. First ring, we're going to go ahead and place 2 electrons there. When we go to our second ring, okay, so when I take those 2 away from 17, that means I've got 15 left that I need to place. But again, I can't place all 15 in that second ring. I can only place 8 of them there. So 2 plus 8, now we've got 10 electrons placed, but I still need to place 17 of them. So I go ahead and I go to my third ring, and when I draw my third ring, that third ring, it says here we can hold 8 electrons, but I only need to place 7 of them. So 2 plus 8 is 10, plus those 7 give me my 17 electrons. Let's look at lithium. Lithium has 3 electrons that we need to place. So again, I look at my nucleus. Can't place all 3 of them in the first ring, so I'm going to go ahead and place 2 there. And then I have 1 electron that's left over. So in that second ring, I'm just going to place 1 electron. Now, here's the thing. When you go ahead and look at the periodic table, you're going to notice that it is made up of patterns. Now, before we go ahead and get to those patterns, one word that I want to go ahead and put up here is I want to use this word valence electrons. Valence electrons are going to be your out level electrons, or the ring that is furthest from the nucleus. So go ahead and say here, it's the outermost energy level electrons. Outermost energy level electrons. So when I look at hydrogen, okay, here's my outer ring. I only have one electron in that outer ring. So hydrogen is going to have one valence electron. When I look at oxygen, okay, 2 in the inner ring, here's my outermost ring, so oxygen is going to have 6 valence electrons. Chlorine, okay, 2, 8, okay, here's my outer ring. Chlorine is going to have 7 valence electrons. And I come back here to lithium, or my last one here is lithium. I've got 2 on the inner ring, and on my outer ring I've got 1 valence electron. Now, again, if you look at the screen and what I've done so far, lithium has 1 valence electron, and so does hydrogen. Now, if we look at the periodic, you see where hydrogen's at? Notice where lithium's at. Lithium's right below it. And again, this had 1 valence electron, that has 1 valence electron. Well, let's just look at sodium real quick to make sure that this pattern continues. So if I go ahead and look at sodium, and from the periodic table, it said 11 electrons. So if we do the orbital diagrams, we've got 2. We go to our second ring, that's going to be 8. And guess what? We have 1 valence electron. Now again, the thing that I told you was this periodic table is going to be made up of patterns. So 1 valence electron, 1 valence electron, 1 valence electron. Guess what? The whole periodic table, again, this whole periodic table is going to be made up of patterns. If that has 1, that has 1, that has 1, guess what? Potassium, rubidium, and cesium, and francium will all have 1 valence electron. Now here's the thing. All you have to do for valence electrons is count across. So again, we can do the first 18 elements. We can go from hydrogen all the way up to argon. But what happens if I give you something like tellurium? The pattern on the periodic table for valence electrons is just count across. That's all you have to do is count across the periodic table. Now we're not going to use this middle portion right in here. These we're just going to have to skip over. We can't do these, and I won't give you any of these on the quiz or the test. But if you count across, first column, 1 valence electron. Second column, 2 valence electrons. Okay, now we're going to jump over here. Again, I said we're going to skip this whole middle portion. Jump over here to this column with boron, 3 valence electrons. Carbon, and this whole column here, 4 valence electrons. 5 valence electrons. Now we did oxygen, and this is number 6, okay, as we counted across. 1, 2, 3, 4, 5, 6 valence electrons. Now let's just double check. Let's find oxygen. Let me go ahead and scroll up here a little bit. Oxygen, right there. 6 valence electrons. Now chlorine has 7 valence electrons. That should be right next to it. That column should be the 7 valence electrons. Let's double check. Okay, right there's chlorine. 7 valence electrons. And then this last one is going to be 8 valence electrons. So again, the pattern on the periodic table, 1 valence electron for the column, 2 valence electrons for the column, 3, 4, 5, 6, 7, and 8. The last thing I want to talk about today is electron dot diagrams. Now, electron dot diagrams, what it is it's really a shorthand representation of an element and its valence electrons. Now, because we're talking about an element and its valence electrons, what you're going to do is you're going to put the element symbol, and then what you're going to do is you're going to treat it like a box. You're going to place the electrons on the right side, and we're always going to start on the right side. And then you're going to go counterclockwise. Then you're going to go top, then you're going to go left, and then you're going to go bottom. So, again, coming back up here, electron dot diagrams are a shorthand representation of an element and its valence electrons. So if we go ahead and look at hydrogen, element symbol for hydrogen is an H. There's only one valence electron, so I'm going to go ahead and put a dot on the right side. If we go ahead and look at oxygen, symbol for oxygen is O. Again, we're going to start on the right side. So I'm going to go ahead and place a dot there. And then I said we work our way around counterclockwise. Never pair up right away. So always go around once. So 2, 3, 4, 5, and 6. If we go ahead and look at chlorine, chlorine, right there, Cl. Chlorine has 7 valence electrons. So 1, 2, 3, 4, 5, 6, and 7. Lithium just has the 1 valence electron. So what you'll do is just have the 1 dot on the right side. Now, what happens if I give you something that you can't do an orbital diagram for? What if I give you something like bismuth? Okay. Now again, we said we can only do orbital diagrams for 18, but remember the pattern I showed you. 1, 2, 3, 4, 5. Bismuth is in the column with 5 valence electrons. Because it's in the column with 5 valence electrons, bismuth would look like this. Okay, symbol. So 1, 2, 3, 4, and 5. Now the last thing I want to quickly talk about is I want to talk about that last column. The last column we said has 8 valence electrons. But if you look at helium up here, helium only has 2 valence electrons. And again, the reason why we say it only has 2 valence electrons is for this reason here. If we go ahead and look at helium, helium only has 2 electrons, and those 2 electrons are going to be here in the first ring. Now, if you look, neon has 10 electrons. And again, I'm going to show you how we get our 8 valence electrons. So we're going to have 2 electrons there, and we're going to have 8 electrons there. Now again, all of the other elements besides helium have 8 valence electrons. So why is helium in that column? Well, we're going to be talking about helium as being one of those gases that is a noble gas where they are unreactive. But let's go ahead and let's look at neon and its dot diagram and helium. So again, neon, 1, 2, 3, 4, 5, 6, 7, 8. If you go around all 4 sides, the right, the top, the left, the bottom, you notice that there are 2 electrons on each side. To show that helium is like one of those gases in that column, notice on a side there are 2. Helium is the only one where we will place both dots on the right side. And that is to show that it matches all of the rest of them having 2 dots on a side. Everything else, though, will go around once. 1, 2, 3, 4, and 5. But again, to show that helium is like the rest of the elements in that column, we'll place both of the dots on the right side.